Greetings, wonderful chemistry students. We are ready for the second lesson in our Spring DLD. This is happening Wednesday before spring break for some of you, and it's happening on the Tuesday after spring break for some of you. But no matter what, welcome to this party. Today we want to verify that you know how to get numbered protons and neutrons and electrons, and we're going to talk about these things called isotopes and average atomic mass. Conveniently, the isotopes were the name of either the softball or the baseball team in The Simpsons. Springfield Isotopes. Well, welcome. So just to review, there's these three things inside atoms: protons, neutrons, and electrons. You can read all about them in the screen in front of you. Protons and neutrons both have mass. Those are the things we're going to mostly talk about today. Electrons are tiny. They have just a tiny amount of mass, so we call it zero, but they do have a -1 charge. Just to review a couple of these things, we're going to use this simulation today. And the thing you're staring at right now is hydrogen. How do you know it's hydrogen? Because it has one proton. Anything with one proton is hydrogen. If I want to change it to helium, it now all of a sudden has 2 protons. This is called helium-4. Look right there, a 4, that's its mass number. It has a mass of 4 because it has 4 things in its nucleus. If I gave it a 5th thing in its nucleus, another neutron, it would turn into helium-5. It would still be helium because 2 protons, but it's a total mass of 5. Dare I put another one in there? Mass of 6? Of course I will. You notice it's unstable. We'll talk about that later. If I were to click lithium, what's going to change? Well, lithium, whoa, it got way bigger, is element number 3. That means it has 3 protons always. And the one you're looking at is lithium-7. I can take a neutron away and turn it into lithium-6. I can take another neutron away and turn it into lithium-5, but it is still lithium. Great. Probably the hardest thing we're going to do today is do a little review of these things. Let's do that right here. This table is something I'm going to ask you to practice in a second. I need you to get good at these tables, and sometimes these just take a little bit of work. So in this first one, it's got 19 protons. What's that mean? Well, you have to look at a periodic table. You have to find something with 19 protons. And when you do, you'll see that thing is potassium. Element number 19. This particular piece of potassium has an atomic mass of 40. That means it has 40 things in the nucleus. But wait, 19 of them are protons. 40 things in the nucleus, 19 of them are protons. So 21 of them must be neutrons because it is potassium 40. Since it does not have a charge, it's going to have the same number of protons and neutrons because protons are positive. I'm sorry, I said that wrong. It's going to have the same number of protons and electrons because protons are positive and electrons are negative. What about this second one? Argon, 40. Always start with argon. How many protons does argon have? Find argon on the periodic table. Argon is element number 20, which means no matter what, it is going to have 20 protons. But this particular piece of argon has a mass of 40. That means there's 40 things in the nucleus. 20 of them are protons. So that means, if you were confused, that means, because I just said argon has 20 protons, but it really is 18. I apologize so deeply. Lead is a big one. Find lead on the periodic table. It's down on the bottom. Element number 82. What's that mean about lead? Well, that means that lead has 82 protons. This particular piece of lead has a mass of 208. Mass of 208. How many neutrons does it have? Well, there's 208 things in the nucleus. 82 of them are protons, so 126 of them must be neutrons. Notice these two numbers aren't the same. This particular piece of lead has a charge of +4. That means it has to have 4 more protons than electrons. And finally, this thing right here. What? I don't know what element it is. It's got 14 neutrons. It's got an atomic mass of 27. It's got 27 things in the nucleus. 14 of them are neutrons. How many of them must be protons? Math, 13 of them. It must be aluminum, 27. So these take some work. I've put a link to this sheet here. This sheet will be helpful for you. This sheet will help you think through how these work. This says beryllium 9. That means it's beryllium with an atomic mass, or an atomic number, a mass number of 9. Beryllium is beryllium, which means it has an atomic number of 4. Beryllium is beryllium. It has an atomic number of 4, so it has 4 protons. It has a mass number of 9. 9 things in the nucleus, so it must have 5 neutrons. And there's no charge. None of these have a charge, so the number of positive things must be equal to the number of negative things. Please pause this video. Take a chance. Try these. See how it goes. This is going to be a thing that gets in your way today. This is going to be a thing you're going to have to think about. We're going to move on, but if you need practice, there's some videos on here. We're going to talk more about isotopes. Well, let's keep going. Question for you. It's a GPA question. See your grades below. Let's say this is for 2 years of school. You have an A, an A, and an A. Good job. And a C, 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 and a C. You know, we can deal with this. We can work with those grades. But my question is, do you have a B average? You've got some A's. You've got some C's. It feels like you should have a B average. Prove me wrong. Ah, you say, you have so many more C's than you have A's. It feels like you might have a B minus average or a C plus average. I don't think you have a B average. And that's the thing we have to do today. We've got to work a little bit on averages. So I've got like some apples, and they're different grades, they're different sizes. These are 50-gram apples, and these are 30-gram apples. And look, I've got 3 of the 50-gram ones, 2 of the 30-gram ones. My apple distribution looks like this. I wonder what the average mass is. Well, I've got some 50s and I've got some 30s, so maybe I could say the average mass is 40. But I don't like that. I feel like I've got so many more 50s than I do 30s that my average mass should be closer to 50. And indeed it is. To find averages like this, we have to find weighted averages. What you really have to do is add up all of your apples, a 50, a 50, a 50, a 30, and a 30, then divide it by how many apples you have. This gives you a 42-gram average. And atoms are like that. Say I dug a hole, and I'm not finding apples anymore, I'm finding atoms, but I find a pile of 100 atoms. But you see, some of these atoms look like this, and some of these atoms look like this. This one has 2 protons and 2 neutrons. This one has 2 protons and 3 neutrons. What can you tell me about these atoms? Both of these atoms have 2 protons, so they are definitely both helium. But they have different masses. This is a helium with a mass of 4, and this is a helium with a mass of 5. When I look at that, here's their symbols. This is a helium with a mass of 4. This is a helium with a mass of 5. I wonder what their average is. Well, there's way more of the 4s than there are of the 5s. There's 87 of the ones with a mass of 4, and only 13 of them mass of 5. So what I need to do is add 4 plus 4 plus 4 plus 4 plus 4, 87 times, plus 5 plus 5 plus 5 plus 5 plus 5, 13 times. Add that all together to get the total mass, and then divide by the total amount of atoms, which are 100 atoms. I showed that down here. The average atomic mass is 4.13, closer to 4 than to 5. One more example, and that is this element. It's just a mysterious element X. Some of them have a mass of 22, and some of them have a mass of 23. And you see from the chart and from these numbers, 7.5% have a mass of 22, and 92.5 have a mass of 23. So my question is, should the average mass be above or below 22.5? you say above 22.5? Because that would be correct. Above 22.5, because more of them are 23 than they are 22. To get the actual mass, I would have to add up all of the ones that have 22 and all of the ones that have 23. That's a little bit harder because I don't know how many. So what we're going to do is we're going to add 22 7.5 times and 23 92.5 times. We assume that we have 100 atoms. And if we had 100 atoms, 7.5 of them would have a mass, stands for atomic mass unit, 22. And 23 of them would have a mass, no, I'm sorry, 92.5 of them would have a mass of 23. Divided by 100. 22.95, which is indeed above 22.5. Turns out, when you look at all of the atoms in the world, they come in different compositions. When I look at all the beryllium in the world, all of it is beryllium 9. When I look at the oxygen in the world, man, most of it is oxygen 16. But some of it, just every once in a while, you get an oxygen 17 and an oxygen 18. You see these random dots. When I look at neon, it comes in two different flavors. Some of the neon is neon 20. Some of the neon is neon 21. Oh man, there's some neon 22 in there too. You can look at all of these different dots. And this works for all these different atoms. They have different compositions. And when they do, they get different average atomic masses. What we're doing is we're not talking about the atomic mass of any individual atom. We're talking about the average atomic mass of all of the chlorine in the world. So I'd like you to play with this simulation a little bit, read some of the links and some of the videos that I've posted on there, and then you do have a Canvas assignment waiting for you. Good luck. Godspeed. Let me know what questions you have, and the DLD Thursday is just a review. Please jump on a Zoom meeting or ask me some questions if you have them on Thursday. Have a great day.